This is a typical calculus question you can get in your grade 12 paper. It says determine f prime of x using the first principle if f of x is 3x squared. So how do we solve this? The first principle formula says f prime of x is the limit as h approaches 0 of f x plus h minus f of x all over the limited h. First things first, I said our f of x is 3x squared. And then I said, how do we find our f of x plus h? We replace the x with x plus h. So this is going to become 3, replacing the x with x plus h all squared. And then from there, we just substitute into our formula, lim as h approaches 0. Now our f of x plus h is 3x plus h squared. So we're going to write 3 into x plus h squared minus the brackets that we should never forget, and then write our f of x is 3x squared, close the brackets, all over our limited h. So first thing, obviously, we need to do away with the brackets. It's going to be 3. Now actually lim, we still have our limited h as h approaches 0, and then 3 into, so we need to get rid of the square. How do we do that? Say x squared becomes x squared, x times h times 2 becomes 2xh, and then h squared becomes h squared. Then multiplying this negative into 3x squared is going to be negative 3x squared over our limited h, which is equal to our limit as h approaches 0. And then we need to multiply this 3 into these brackets. So 3 times x squared is going to be 3x squared. 3 times 2xh is going to be plus 6xh. And then 3 times h squared is going to be plus 3h squared minus the 3x squared that was already here, all over our limited h. So collecting like terms, we have 3x squared minus 3x squared. They will add up to 0, and then that's it. So we are left with lim as h approaches 0 of 6xh plus 3h squared, all over our limited h. Both our terms do have h in them, so we can take out the common factor of h, still giving us the limits as h approaches 0. Taking out the common factor h, we are left with 6x plus 3, and then dividing by h here, it only cancels the square, so we are left with 1h, 3h, all over our limited h. So then this guy is going to cancel our limited h, leaving with the limits also, and then we are left with 6x plus 3h. So we no longer have a limit, so what do? Our h now reaches 0, so it's going to be 6x plus 3 times 0, so which is going to be 6x. So that's our final answer. And if we check, f of x is 3x squared. So if we use the power rule to check if our answer is correct, it's going to be f prime of x, then the power is 2 times 3, which is 6x to the power of 2 minus 1, which is going to be 1. So 6x, therefore our answer is correct. So going to 1.2, it says find the derivatives. So our first question, 1.2.1, says if f of x is equal to x squared minus 3 plus 9 over x squared. So how do we do this? We first check if our equation consists of any brackets. So there are no brackets. And then the second step, we check for the roots. There are no roots. The third step, we check if we can find any x in the denominator. And of course, we have x squared in the denominator. So first things first, before we derive, we need to simplify the equation in such a way that we do not have that x in the denominator. So simplifying this, still gonna be f of x is equal to x squared minus 3 plus 9. So how do we get rid of the x squared in the denominator? We raise it and multiply to the 9 on the numerator. But then if we do that, the exponent is going to change. Using the laws of exponent, it's going to be negative 2. So it changes into a negative exponent times x to the negative 2. So now doing our checkups again. So no brackets, no roots, no x in the denominator. So we can now go ahead and derive our equation. So f prime of x is going to be, so the power rule, 2 times the number in front of x, it's going to be 2, x to the power of 2 minus 1, which is just 1, so there's no need to write 1 over there. This is negative 3, so deriving negative 3, that's a constant, it's going to be 0. And then this is x to the power of negative 2, so the power negative 2 times the number in front of x, which is 9, it's negative 18, times x to the power of negative 2 minus 1, which is negative 3. So there is our derivative, which you can go further and simplify to being 2x minus 18 over x cubed. So our second question, 1.2.2, says y is equal to bracket root x plus 3, close bracket, open bracket, root x minus 1, close. So before we get into this question, if you were confused by the previous questions, make sure you go to the description, click on the link. There's a link which will take you to a course that I made where I explain everything that has to do with calculus, how to do the first principle, how to derive using the power rule, and how to find the equation of a tangent, and how to plot the cubic functions, how to factorize the cubic functions. Even if you have the blue or pink calculator or the gray calculator, you can still factorize the thing. So I went extensively and explained everything you need to know about the grade 12 calculus. So doing our checkups, do we have any brackets? Yes, we have brackets. So we need to do away with the brackets first. So simplifying first before we can derive. Root x times root x, multiplying two brackets, root x times root x, that is the same thing as root x squared. The squared will cancel out the square root, so you're going to be left with x. And then root x times negative 1, it's minus root x. And then 3 times root x is positive 3 root x. And then 3 times negative 1, it's negative 3. So that gives us x minus, no, actually plus 2, if you add these like terms, plus 2 root x minus 3. So we don't have the brackets anymore. So our second thing that we need to check, do we have any roots? Yes, we do have root x, so we need to remove that thing. If we have x being inside the roots, we can't derive that thing. We need to first get rid of that root. So what we need to do is y is equal to x plus 2. So what I said was you rewrite x, and then it's x to the power of 1 here inside the roots, so it's going to the power of 1 over the 2 that's here, because since it's a square root, we have the 2 outside, which we don't usually write, but it is a 2. So our exponent becomes 1 over 2 minus 3. Doing our last checkup, do we have any x in the denominator? No, we do not. So we are clear for differentiation. We can now go ahead and say dy over dx is equal. So x differentiating x is x to the power of 1. So the power 1 times the number in front of x, which is 1, is just going to be 1. And we are going to be left with x to the power of 1 minus 1. And I told you x to the power of 1 minus 1 is x to the power of 0, which is going to be 1. So it's going to be 1 times 1. We are left with 1. And then going on to the second term, we have the power 1 over 2. So 1 over 2 times 2, it's going to be 1 also. And then times x to the power of 1 over 2 minus 1. So 1 over 2 minus 1 is negative 1 over 2. So it's to the power of negative 1 over 2. And then we have minus 3. That is a constant, so it becomes 0. So this is our answer for this, but we can still go ahead and simplify and say it's 1 plus, drop the thing, so say it's 1 over x to the positive 1 over 2. And then we can go ahead and say 1 plus 1 over, so x to the power of 1 over 2 is obviously the square root of x. And that is it. You can go ahead and get your full 12 marks. This was a question for 12 marks, 5 marks for the first question, 4 and 3 for these two questions. So I had to show you that there is no reason for you to not get the full marks when it comes to these kind of questions in calculus.